Hello friends, welcome to Genius Books. I'm Vinod Kadakol, IAS Monk. Today we are looking into this wonderful series of maths ability with respect to CSAT. CSAT means IAS Preliminary Exams Paper 2. Okay, whatever questions they have asked in that paper, in that year, I'm going to solve here one by one. So, this is Mental Ability Free Masterclasses series targeting IAS 2024. Okay, CSAT means Civil Services Aptitude Test. Okay, normally it contains, let me show you the syllabus. Okay, yeah, this is the syllabus for IAS Preliminary Paper 2. Whenever we say IAS, it's not just IAS, it is Civil Services exam. Okay, it's a combined, there are more than 20 services altogether. CSC, that is Civil Services, Combined Civil Services exam. We say IAS because everyone wants to become an IAS officer. So that exam is IAS exam. Okay, fine. I did not repeat this each time, it is understood. So this is the syllabus for IAS Preliminary Exam Paper 2, which is popularly called as CSAT. Okay. So what is the comprehension, then interpretation, interpersonal skills, including communication skills, logical reasoning and analytical reasoning, decision making and problem solving, general mental ability. Okay. So they are all reasoning, logical as well as analytical. Next comes the basic numeracy, that is numbers and their relations, orders of magnitude, etc. Okay. Data interpretation, that's all charts, graphs, tables, all those things. So this general mental ability and basic numeracy, these together form what is known as quantitative aptitude. It's all maths. Along with this, reasoning, analytical as well as logical. And it might include verbal as well as non-verbal. All those things we'll see separately. Here in this series, I am going to give you lectures on maths ability, that is particularly numeracy and general mental ability. Okay. What I am going to do here is, in each episode of this series, I am going to pick questions from previous year question papers with PYQs, and I am going to solve those things here. Okay, by learning these things, how to solve these particular problems, you will become familiar with maths. So don't be afraid of maths. Particularly this year's exam, 2023 IAS Preliminary Exam Paper 2, it was a toughest one. That's what the general opinion. Okay. Some people even went to court saying that to scrap this particular paper. Actually, it was not that serious. If you look into the question paper, the questions asked were very simple. But people, I don't know why they think so, because they have not seen other exams and all those things. All these questions are solvable. These questions are not new. These are not from CAT or MAT, the entrance for MBA, all those things. People were unnecessarily alleging that the questions were of that level. No, it's not like that. If you look into the questions, many of the questions were asked in other exams, other SSC exams, Staff Selection Commission exam, and then CDSC, Combined Defense Services exam, even some bank exams. So questions have been appeared. It's not new. It's not something of very high standard or not solvable. These are very simple problems, basic problems. See, out of these, paper 2 will contain, 80 questions. Okay, 80 questions. Each question will carry 2.5 marks, so that the total number of marks is 200. Out of this 200, you have to score just 33% to qualify in this paper 2. Only then your paper 1 marks will be considered for merit. Merit means to qualify for mains, to write main exam. Okay, just scoring 33% out of 200, that means it will be 66 marks. Just 66 marks out of 200. It's a very simple thing. Why people are making a big thing out of this, I don't know. Okay, let us go into this question paper, particularly 2023 question paper. We'll solve. We'll start solving questions one by one. In each episode, I'm going to solve some at least 5 problems. And the next episode, I am continuing again with 5 more problems. Like that, we'll cover this entire series. Mass or quantitative aptitude, mental ability, CSAT, we call all those things by whatever name. It's all numbers. My dear friends, have you found or do you find any number in any shop, any mall? Where are those numbers? 1, 2, 3, 4, 5. We don't know. What are these numbers? Can you get these numbers anywhere in nature or in any shop? No. It's all our abstract concept. We get the concreteness of these numbers by relating these numbers to objects. We say 1 apple, okay, 2 apples, 1 apple and 2 apples. So with the feel of those apples, those concrete things, we can understand the abstractness of the numbers. So 1 apple gives me the oneness, that abstract concept, that oneness, two-ness, three-ness. So that will be understood through the concrete objects. Otherwise, there are no numbers existing in nature. It is not an object. Okay. So when we talk about numbers, we are not supposed to forget this Pythagoras, Euclid. They are all the people who gave us these wonderful concepts, and I don't know what I should say about these numbers. Pythagoras considered numbers as persons. They exist. They personified these numbers. In fact, number 1 represented God. Okay, number 2 represented female. Number 3 represented male. So these were the ideas developed by Pythagoras, and he founded a secret society, the members of which are called Pythagoreans, the followers of Pythagoras or students of Pythagoras. Pythagoras was master. Okay, you know this famous theorem, Pythagoras theorem, about that right angle triangle. Okay, and two shorter sides of a right angle, right triangle. The square, when you square those two sides and add them, you are getting the square of the other longer side. That is what we call hypotenuse. Okay, so that is a famous theorem, but it's all geometry. But I'm talking about here numbers. Okay, Pythagoras is known by his theorem, but that was not the only work what he did. He worked in many things, many other things. He about numbers, especially about numbers, and he was a musician. He said, "Number this all this universe is made up of numbers." Numbers for him was like atoms. Okay, the importance of numbers. Okay, whenever you get pleasant sound, it is connected to a whole number. That's what Pythagoras said. He himself was a great musician. He used to play lyre. It's kind of, you can say, guitar with only one string. Whatever it is. So, whatever the pleasant sounds, the harmonic notes, what we get when we play some musical instrument, it is connected to numbers. That's what he said. Because of that, Pythagoras, he strongly believed that the entire universe is made up of numbers, because you are getting 2 after adding 1 to 1. Again, you are getting 3 when you copy that 1 3 times. That's what his concept. Okay, so when we talk about numbers, when we talk about maths, we have to start with Pythagoras, Euclid, and many more wonderful persons connected to this field. It's not just Western people. Even in India also we have so many Bodhayana. Because of his that trigonometric concepts were developed. After that we talk about Aryabhata, Bhaskara, Brahmagupta, who gave the concept of zero to word. So all those we also have so many stalwarts. But let's stick to what we are doing right now. We are solving this question paper because there is basic numeracy in syllabus. Because of that I am talking about numbers. When we talk about numbers, we cannot forget all these people. So that's why. And maths, normally when you were in school, you used to love geometry more than these numbers and all the formula, whatever theorems uh, we used to get there. Geometry is most fascinating subject for any child. Okay, so that is how math started. When pyramids were built, okay, pyramids of Egypt, they knew only about few numbers, maybe maximum up to 3. One is just one, myself or whatever one object. 2 is yourself, and 3 is more than 2. So more than enough. So their counting system ended at the most by 3. That's all. Before that, there were no numbers actually. Only they used to count in terms of 1, 2, and many. That's all. 1, 2, myself, yourself, and all others. So when pyramids were built, these pyramids were built in around 2500 BC. Okay, that time the Pythagoras, his time was around 579. He was born in 579 BC and died around 499. Say he he was alive for almost 80 years. So pyramids were built in 2500 year. That was BC, before Christ. Okay. Now, what I am trying to say here is mathematics, what we know today, it started from geometry, different concepts, and during Pythagoras' time, there was no symbol for 0. But even then, he considered number 10 as the most perfect number, because if you add first four numbers, you are getting 10. So that is how Pythagoras concluded that 10 is the most perfect number. 1 is God, he said. Okay, so Pythagoreans, they personified numbers, and they developed this concept of numbers or the atoms of this universe. Everything is made up of numbers. That's what they used to teach. So that number 10 in during Pythagoras time, they used to write those numbers with dots. One for one dot means number 1, 2 dot means number 2, like that. They used to represent this 10 by a beautiful triangle. How? At base they used to put 4 dots, then above that 3, above that 2 more, and 1. So this will give you a wonderful, a beautiful symmetrical triangle. This is what number 10 for Pythagoreans. Okay, that's all history. Now, looking at this first question, if P, Q and R and S are distinct single digit positive numbers, then what is the greatest value of P plus Q and R plus R? This is the question. In question paper, this is question number 36, D series. This is 2023 IAS Prelims question paper 2. Okay, question paper 2, and then series D. In that question paper, the number is 36. Here I have taken it as question number 1. Okay, so I am starting with numbers, the basic numeracy part. Okay, so this question is very, very simple. What is wrong with this question? Is it so difficult? No. See, the entire out of 40 questions they have asked from this section in that question paper. See, almost 80 questions are there in that question paper. Out of 80, 40, almost 50% questions are on this CSAT, that mental ability part, quantitative aptitude, maths ability, you can say. So 40 questions they have asked. Most of the questions are very, very simple, based on your basic odd number, even number, remainder, okay, and prime numbers. That's all. Don't you know what is an odd number? What is an even number? The concept of remainder. It's all based on these simple basic things which you have studied in your class 5, 6, 7, 8, 9, 10. What is an odd number, even number, prime number? You know all these things, only that you have to apply those things. That's all. Don't be scared of any kind of maths problem. Okay, I am here to teach you one by one. Okay, I'll give you the history of that concept, and I solve that problem also, so that you will become more smarter. Okay, no coaching institute will teach you like this. Bear in your mind. Okay, so this is all. It's all the result of my 20 years of experience. I am involved in deep studies. I am studying almost all the subjects. I am developing a kind of, I don't know what I should say. I am not boasting myself. I am just asserting myself. The result of all the past 20 years of my involvement with this exam and with the subjects which I am very much interested in. Okay, so here the thing is, don't be afraid of, don't be scared of maths. That is my simple mantra. Okay, if you face it, if you solve it, you will definitely become familiar with those things. It's a kind of game, okay, number game, that's all. So let us see this problem. It's This is a very simple problem. If P, Q, R and S are distinct digit single digit positive numbers, then what is the greatest value of P plus Q, R plus R? Very simple. See, let me put this question in a different manner. It involves a very wonderful concept of a simple, basic concept of geometry. That's why I am talking about pyramid. So, pyramid, it has a square base. Okay. The base is square. What is the area of the square? I am talking about the biggest, largest pyramid. Okay, near in Egypt, near Cairo outskirts, you say you might have heard about this Giza pyramid of Giza. So its base is square and its area is around 13.1 acres. Just imagine how big it is. Its base area is 13.1 square meter. Each side around 229 meters. And height of this pyramid, height is around 146 meters. Okay. So it all started with geometry. Okay, numbers and all. In 2500 BC, people were not so much used to the numbers which we are using now. So it's all about shapes and measurements and geometry. That's all. Now here this question, if I ask you, suppose there is a farmer, okay, he wants to build a fence around his rectangular field, and the perimeter of that rectangle, okay, the perimeter of that perimeter, you know, okay, so perimeter of that rectangle, if you add all the sides, you know what is rectangle? So L plus B plus B. This is what perimeter. You know all these simple things. So I did not keep on explaining each and everything. So the perimeter is L plus B plus B. So perimeter of this rectangular field is, let us say, 30 meters. Now that farmer wants to build a fence around his field. So this question I am framing in a different manner. So what should be the maximum area if he wants to cover the maximum area of his field with perimeter of this 30 meter? What are the dimensions of his rectangle's sides? That is the question here. The same question is in different form. Okay, here what is given? I'll come to this after solving this problem. So if P, Q, R and S are distinct single digit positive numbers, so there are only 9 numbers from 1 to 9. If you include 0, it will become 10 digits. So 1 to 9 is the range in which you can get these distinct single digit positive numbers. So P, Q, R, S or 1 to 9, from these 1 to 9 they can be any number. So question is, what is the greatest value of P? You are adding those distinct single positive numbers and multiplying them in this way. So you should get the maximum product. So in this case, what should be my P, Q, R and S? This is the question. So P can be, you have to get maximum value. So you have to choose 9, 8, 7, 6, Okay, so that you will get this maximum value. But the thing here is how you are going to arrange this 9, whether 9 plus 8 or 9 plus 7. How are you going to arrange these things? Let us try. I am sure that PQRS are 9876. We don't know what is PU, what is R, Q and other things. Let us try these things. So this is the given situation. Let me try P as 9, Q as 8. Remaining numbers are 7 plus 6. This is equal to what? We'll calculate. Let us try again one more. 9 plus 7. Here remaining things are 8 plus 6. Let me try this as 9 plus 6. This as remaining things are 8 plus 7. So how much it will be? 9 plus 8 is 17. 7 plus 6 is 13. 9 plus 7 again 17 into 14. This is 15 into 15. So this will be around what? 13. See how to multiplication, addition, these are all very simple things. How you multiply this? First take this 17 and multiply this 10. You are getting 170. So without pen you have to calculate such simple things. Then only you can maintain that speed. Right. So 17 into 13. How to multiply these things? First multiply 17 with 10. You are getting 170. Then 17 into 3 is what? 51. So then add 170 plus 51, it will be 221. Similarly, 17 into 10 is 170, 17 into 4 is 68, 170 plus 68 is how much? How much it will be? (170) plus 68. Will it be 238? No, here it is wrong. This is 16 actually. 16 because 9 plus 7 is 16. So 16 into 14 is how much? 16 into 10 is 160 plus 16 into 4 is 64. It will be 224. Okay. Now 9 plus 6 is 50, 8 plus 7 is 15. What is 15 square? That is 225. See, among the given things, 15 into 15 you are getting the largest value, that is 225 square meters. Here it is 224, here it is 221. Okay. So my numbers should be P is 9, Q is R 6 and R is 8, S is 7. Then you are getting 225. So this is a maximum value that you are getting. Answer will be B. See the beauty of this. That farmer, if he had planned his fence in a rectangular this thing, considering, see, these are all 9 plus, suppose this is total perimeter is what? 30. 9 plus 8 plus 7 plus 6, that is 17 plus 7, 24 plus 6 is 30. 30 is the perimeter. For rectangles, he can make it as 9 and remaining thing is what? 6. But if he plans a rectangle of equal sides, that rectangle is called a square. This is he should have 15, 15, 15. All together you should have 7.30 by 4. How much it will be? 7.5, 7.5, 7.5 and 7.5. So my each side perimeter will become 15 plus 15. Then it will become square. Then we can get maximum area. That's what it means, 225 square meters. So compare this rectangle and square. If the square has more area compared to the rectangle, even though perimeters are same, is it not a mysterious thing or surprising thing or a beautiful thing of geometry? If the perimeter is same, if use that perimeter to form a rectangle whose area will be lesser than the square with the same perimeter. This is what, see, this is rectangle with perimeter 30 meters. This is square with perimeter again 30 meters. But this area is more because it has 225 square meters. Other rectangle, they have lesser areas compared to this square. So here this concept is involved in this problem. If you know about geometry, if you know about squares, if you know about rectangles, if you know about pyramid, if you know about all those people, it's very simple. So the thing here is mathematics is not a tough thing to understand. You have to evolve your method of studying, understanding the things. That evolution should be there. So once you evolve through your process, that's what from primary school to secondary school to college and all those, that evolution should be there. Then you will be ready to face any kind of problems which you don't feel difficult at all. Okay, so this evolution is required. See, this is a very simple problem connected to rectangle and square. If you consider the same perimeter of a rectangle and a square, areas will be different. Square has maximum area. Why it is so? I can give you lecture on this question hours together, but I don't have time here. The simple thing, to put it in one line, I'll say the central tendency. Okay, central tendency. See, here we have considered 15, 15. Here 17, here 13. So in case of these four numbers in this particular problem, I am talking about the extremes. Here extreme things are, one is 6, another is 9. So when you consider extreme points, your central tendency is somewhere in between those two extremes. That's what we say arithmetic mean or average, whatever it is. So central tendency will give you the maximum value. So it gives you an idea of maximum product or maximum value. So here 17 into 13, 17 is not, it doesn't indicate central tendency. 13 is also, it is away from central point. 13 is 13 and 17 both away from that central point. Central point here is 15. So if you consider both 15, 15, you are getting maximum result. So that central tendency, it comes in statistics, all those things. But the simple thing here is the same perimeter, area of rectangle is less than area of square. So that's what this problem is all about. Let us move on to next problem. I should not take much time for such simple problems. Okay, next problem is question number 2 here, and that is in question paper D series 2023 IAS Prelims question paper 2. D series, there question number 20. Now in this episode, this is free master classes for you. In this series, question number 2. Okay, choose the group which is different from the others. Okay, how you start this problem solving, how you start solving this problem. Look at these numbers, they are all very, the striking point here is, see the digits 7, 7, unit unit place digits, 7, 7, 7, 7, 1, 3, 3, 3. So the first thing what I note here is all are odd numbers. There is nothing even. You try to find, is there any even number? No, I am not finding any even number. What are odd and even numbers? This concept was given by Pythagoras. Okay, so the history goes back to 579 BC when Pythagoras born. Okay, Pythagoras is a wonderful person. He was contemporary of our Buddha. I am planning to write one book comparing Buddha and Pythagoras. Okay, it is a future plan. So Pythagoras, he started all this things. See, odd, even. What are odd numbers? What are even numbers? Even rational numbers. See, you know about different kinds of numbers. When you start counting numbers, all these 1, 2, 3, these are all natural numbers. We say counting numbers. If you add 0 to it, these become whole numbers. Then what? Integers, positive integers, negative integers. Then comes rational numbers. What are rational numbers? Those numbers which can be represented in the form of P by Q, where Q is not equal to 0. This is what you learn in your primary schools. Okay, so any number can be expressed in this form. For example, 2 can be expressed as 2 by 1. For example, 17, it can be expressed as 17 by 1. These are all rational numbers. Okay, then comes irrational numbers. What are irrational numbers? Those numbers which cannot be expressed in this form. Those are all irrational numbers. My dear friends, it is not so simple. There are so many recurring decimals, non-recurring decimals, non-recurring, unending, never-ending decimals. What are those? Those are irrational numbers. We talk about those numbers later. Right now, these group of numbers, they are all odd numbers, not even numbers. Okay. So I hope you don't want definition of odd number or even number from me. Okay. I'm not going to define all those things. Please find out yourself if you don't know. I hope you know all these things. It's a very simple thing. Okay. Okay, here in this particular problem, what I am finding is the most striking point looking at this problem. The very first striking point what I note here is these are all odd numbers. Then how I should select my answer? The question is, I have to choose which group is different. All are odd numbers. Then comes, wow, prime numbers. What are prime numbers? I hope you know. Those numbers which have only two factors. Only two factors. What is a factor then? My dear friends, if you don't know, I'm sorry. I imagine that you all know such simple things, but even then I give you just one line explanations. Okay. So prime is a number which has only two factors. What is a factor? Factor is simply a divisor which divides a given number completely. Completely means what? Without leaving any remainder. So remainder will be 0. All these numbers are called prime numbers. So prime number, what are those two factors? 1 and that number itself. Okay. For example, if I am taking 4, 4 can be divided by 1, then what? 2, and the number itself 4. So these are the factors here. Factors are, they are also numbers, but what kind of number? They are divisors. What kind of divisors? They divide the given number completely. That means without giving any remainder. Remainder will be 0. So if I divide 4 by 1, remainder is 0. If I divide 4 by 2, it is remainder will be 0. If I divide by 4 by 4, remainder will be 0. Okay, like this 4, 4. This is quotient. 4 ones are 4, and this is remainder. Okay, so remainder will be 0. These kind of divisors are called factors. So prime numbers have only two factors, 1 and the number itself. Those numbers which have more than two factors are called composite numbers. Okay, composite numbers. For example, 4 is not a prime number because it has three factors, 4, 2 and 1. It is not a prime number, it is a composite number because it has more than two factors. So the minimum basic qualification for any number to become a prime number is it should have only two factors, and those two factors are 1 and that number itself. So if those two characters are satisfied, then we can call that number as a prime number. And all primes are odd numbers. This is one character. All primes are odd numbers. Please remember this. But converse is not true. All odd numbers are not primes. Because 9 is an odd number, but it is not a prime number. Why? Because it has more than two factors. 1, 3 and 9 itself. So it's not a prime number, but it is a odd number. So even though all prime numbers are odd numbers, all odd numbers are not primes. Please remember this, because this character, this principle is applied here. Here given numbers, all numbers which are given in 4 groups A, B, C, D, they are all odd numbers. We know that all prime numbers are odds. Here we are given a group of odd numbers. We know all primes are odds. Here all numbers are odd numbers. But we also know that all odd numbers are not primes. Let us find now, is there any prime number in this? Is there any composite number in this? Let us see. 17, 17, 17. Oh. 91 is not a prime number. Okay. How? Because it has more than two factors. How? Okay, find the, factorization, prime factorization, how to do about LCM, HCF. They are very simple, class 5, 6, 7 concepts, problems, okay. So, what are the prime factors of 91? 13, 7 and 1. Okay. So 13, the number itself, and 1, these are two factors. Along with this number has one more factor, 7. So it has three factors. That is why it is not a prime number. 91 is not a prime number. Even though it is odd, it is not a prime number. Remaining all other numbers are prime numbers. Okay. So my answer should be D. My dear friend, there are Euclid, you must be knowing. This person is Euclid. Okay. In 300 BC, he proved that there are infinite number of prime numbers. Okay. Infinite number of prime numbers. We can start. 1 is not a prime number because Prime number, it should have two factors, whereas it has only one factor. It is a special prime number, you can say, or don't say it is a prime number. 2 is, the beauty of 2 is, it is first, the only even number which is prime. Then comes 3. 3 is actual, a pure prime number, you can say. 4 is not a prime number. 5. So if you go on like this, there are infinite number of prime numbers. How to find these? How to find these prime numbers? One tool was given by Mr. Eratosthenes, this person. 276 BC, he is junior to Euclid. He gave one tool. It is called Eratosthenes sieve. Okay, what he said? Write down all the numbers. For example, 1 to 100. 1 to 100 will contain 25 prime numbers. Okay, 1 to 100. If you see, it contains 25 prime numbers. From 101 to 200, it contains around 21 prime numbers. Like that, till 1000, 1 to 1000, we get around 168 prime numbers. That means what? If you go on and on and on till infinity, the number of primes will reduce, right? It doesn't mean that somewhere it will end. That's why Euclid said it is never ending, you will get infinite number of prime numbers. That's what he said. Eratosthenes, he gave one simple tool for us to find out prime numbers. That is what is called Eratosthenes sieve. What he said, you write down numbers, say for example 1 to 20, then or 1 to 100 or whatever, in what range you want to find your prime numbers, that range you have to write continuously. You go on writing 1 to 100. So then what you have to do, next step is, first 1 is not a prime number, so don't consider it. 2 is a prime number, cancel it. After that, you have to keep on cancelling or crossing multiples of 2. Okay, multiples of 2, that is what is this. So 2 cancelled, then 4 you can cancel. Similarly 8, then 6, 8, 10. Like that you go on cancelling multiples of 2. 2, 4, 6, 8, okay, 10. You have to cancel all those things. Next, if you are considering up to 100, 100 also you can cancel. Then remains 3. 3 is a prime number, and go on cancelling the multiples of 3. Then you are getting whatever number is there. 3, 6 already cancelled, and 9 you have to cancel it. So you have to cancel multiples of 3. Then next prime number is what? You are left with 5 here. Take 5, it is also prime, and then go on cancelling multiples of 5. Like this, you keep on cancelling each multiples. So whatever you are up to 100, if you are considering, so whatever you are left with at that point, you will be remained with those numbers which are not cancelled. All those are prime numbers. So from 1 to 100, you don't want to say 1, say 2 to 100, because 1 is a special number. It has only one factor, 1. The number itself is also 1. So it is not considered as prime number. 2 is even prime number. All other prime numbers are odd. And all odd numbers are not primes. Please remember this. So if you consider from 2 to 100, apply Eratosthenes' principle, sieve. Sieve is, put all these numbers 1 to 100 and save it. All those things are cancelled and you are remained with the prime numbers. The thing here is you will get around 25 prime numbers from 2 to 100. Okay. So this is how you have to find. There are so many, of course, there are other formulas which is not required here. All those, you get 2 raised to n minus 1 minus something, all the format, Wilson's principles, Fermat's principles, all those are higher class studies. We need not bother about those things. So right now you should know what is a prime number, what is a composite number, what is an odd number, what is an even number. These are all school maths. Okay, nothing complex in this. So this is the answer for your question number 2 here. So now let me know, is these questions are unsolvable? No, I don't think so. They are very much solvable. Okay, next comes, yeah. What is the remainder when 85 into 87 into 89 into 91 into 95 into 96 is divided by 100? Oh my god, you have to multiply all these things. See, in this exam, you will be having around 2 hours. If you keep multiplying this thing, how you will do, how you will manage all these things? Okay, my dear friends, you need not multiply such things. The intention of UPSC or this exam is not to make your time waste here. Okay, you are not supposed to multiply all these things. Even if you keep multiplying, it will take 2 hours. Okay, even if you use calculator, you are not allowed to use calculator. It will take more than 2-3 minutes. Okay, so this here idea is you are not supposed to multiply this. That is one thing. Okay, don't keep on multiplying these things. Then what I should do? Okay, see what is the thing here. This number, whatever it is, after multiplying all these two-digit numbers, whatever you are going to get, that product, that number, whether it is divisible by 100 or not, that is the question here. Divisible means remainder should be 0. So what is the remainder when this number is divided by 100? So first you have to check whether this number is completely divisible or not. If it is not divisible completely, then you will get some remainder. So he is asking for what is that remainder if this number is divided by 100. Okay, the first thing what I should do here is the number which can be divided by 100. What kind of that number should be? Take any number. See, you know about test of divisibility. What number is can be divided by 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 17. So you have studied all this in your primary school. Okay, test of divisibility. That is most important. That's for other problems in this particular exam. The test of divisibility is very, very important. Okay, see all the 40 questions, out of 40, almost 30-35 questions are based on this prime numbers, odd and even numbers, and test of divisibility. That's all. So why are you afraid of this mathematics, CSAT? Why are you going to courts? Why you are blaming UPSC? No need of doing all such things. You see the questions, understand the things, and try to recall whatever you have studied in your schools. If you have not understood, if you are not remembering things, don't blame UPSC or IAS exam. Blame yourself. Consult people like us, consult different books, and try to come out of this ignorance. Okay, so here for any number to be divided by 100, it should contain two zeros, where its last two places. This is unit place, this is 10th place. So whatever the number is, A, B, C, D, and last two digits should be 0. Then only I can divide this number. These two 0 gets cancelled, giving out this remainder. Sorry, this number, and remainder will be 0. So here, what about this? How I can get two zeros? How you get two zeros? If you multiply 2 with what? With 5, then you will get 1 0. If you multiply again by 2, you will get 0. So, if you multiply some other number other than 5, you are not going to get 0. Okay. So the point here is that these multiples should contain at least one 5. Anything, any number, not thing, anything, any number multiplied by 5 will give you 0 or 5 at its unit place. So you should get 0 by multiplying 5 with numbers either 2 or 4 or 6 or 8. Okay, these are all even numbers. So if you are multiplying 5 and 2, because all these 4, 6, 8 are all multiples of 2. So you should look for at least 1 5 and 1 2. Okay, in this number I have here 1 5 and 6 is there, it is multiple of 2. So I can get here 6 is 96 is what? 24 into 4. So I am getting 4 there. See, 96 is 24 into 4. So this 4 I am getting in this 96. So this 4, it actually 2 into 2. And 1 5 is here. One more 5 is here. I have 2 5s and 2 2s. So I am getting 5 into 2 is 10, into 10 I am getting 100. That means what? In this number, after multiplying all these numbers, you are getting a number which has 2 zeros at its last 2 places, that is units place and tens place. So whatever be the other digits, I am not bothered about it. I want only 2 zeros at the end. I got it. So this can be divisible by 100 and it's not giving any remainder. That means remainder is 0. That should be your answer. Okay. So this is remainder problem, and next problem is this. Wow, I love this problem. 2 raised to 192, my god. 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8. So like that, 2 raised to 192 is what? And you have to divide this by 6 and then see what is the remainder. Oh my god, such a difficult question, right? So this problem is also on remainder. See, first problems were on prime numbers, odd and even numbers, and here again remainder. So how to do this? For this you have to find the pattern. See, these are all called powers of 2. 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 192. These are all powers of 2. So when you divide the powers of 2 with 6, what you will get? For such things, whenever you come across such a strange number with a huge power, 2 raised to 192, 2 raised to 5000, something like that, what you have to do? You have to find the pattern. These are the patterns. Okay. Again, now if I go on dividing the powers of 2 with 6, I am going to get one pattern here. See, 2 raised to 1 is what? It is 2. You have to divide this 2 by 6. That means what? Let me write it in like a third standard boy I am writing. I am dividing 2 by 6. What I will get? 6 is my divisor. Then 2 is my dividend. 6, I cannot divide this. Then what I should do? 0. 0 is my quotient. 6 0 is what? 6 into 0 is what? 0. These are all nursery, primary school, nursery class things. I remember my daughter used to say when she was in nursery, 0 means nothing, something like that. Children are very, very smart, she used to say 0 means nothing. That is how we learn since our childhood. We don't know what is 0, what is the concept of 0, what is the concept of numbers. We don't know all those things. But we learn. Our brain is such a wonderful thing. So, okay, I don't want to divert the things. So, 0 means nothing. 6 into 0, nothing. So, 2 minus 0 will be 2 only. So, quotient is 0, whereas remainder is 0. So, when I divide 2 raised to 1, I am getting remainder as 2. Okay, again let me divide 2 raised to 2. What will happen? 2 raised to 2 is what? 4. Okay. 2 raised to 2 is 4. 2 raised to 3 is 8. So 2 raised to 2 will be 4. I am dividing this by 6. Again I cannot divide. So 6 into 0 is 0 again. Remainder will be 4. Come to 2 raised to 3. It will be 8. So I will divide 8 by 6. Because they have asked in question, you have to divide by 6. So yeah, I can divide this 8 now. 6 1s are 6. Remainder is 2. Fine. Remainder is 2. Come to the next power of 2. 2 raised to 4. 2 raised to 4 is what? 2 into 2 is 4. 4 into 2 is 8. 8 into 2 is 16. Yeah, I can divide this also by 6. 6 2s are 12 and remainder is 4. Wow, I am finding a pattern here. See, whenever the power of 2 is odd, 2 raised to 1, 2 raised to 3, I am getting remainder as 2. Okay. Whenever my power is even, power of 2 is even, 2 raised to 2 or 2 raised to 4, I am getting remainder as 4. This pattern will continue, my dear friends. So when the power of 2 is even, you are getting 4 as remainder. When the power of 2 is odd, you are getting 2 as your remainder. So this 2 4 2 4 will continue. 2 4, this is even, you are getting 4 as your remainder. Okay. This is for this is sorry. For odd power, you are getting 2 as remainder. For even power, you are getting 4 as your remainder. Fine. So, what is 192? It's odd or even? Straight away, even. Even numbers are those numbers which are divisible by 2. So, 192 is divisible by 2. So, it is an even number. It is power of 2 here. So, whenever power of 2 is even, what you should get? Remainder. It is 4. So, irrespective of the power, you can just say, looking at whether it is even or odd, you can say remainder is, since the power 192 is even number, remainder will be always 4. If it was something 193 or 191, then remainder would have been just 2. Understood? So for such things, you have to find the pattern. Okay, we'll go to the next problem. That is, again, I am giving it you as, yeah, wow. See, the base is 57,242. For this base, it is raised to, the power is 9 into 7 into 5 into 3 into 1. What is the unit digit in the expansion of when you do this? Suppose this is asking like this. Suppose 2 raised to 2 into 3. What is the digit in the expansion? If I expand this, what will happen? 2 raised to 8 will come, 6 will come. So that means 2 into 2 into 2 into 2, 6 times. This will give me 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64. So this is the expansion. So what is the unit digit of this expansion. Here it is 4. So you have to do the same thing for here. But first you have to multiply this 97531. Then find out what is this. It is not so simple. I have taken the only 6. So this is not 6. This is you find out how much it is. Then you have to multiply this number that many times, which is a very laborious task. It will take almost 1 day if you keep on doing it. But how to do this? You have only 2 minutes. Again, my dear friend, follow the pattern. This particular problem, I leave it to you. You please solve it, try to solve it. I'm going to end this episode here only. In my next episode, that is series 2, Maths series, free masterclass, whatever I have written that, okay. In my next, that is episode number 2, I am continuing from where I have left right now, okay. So this problem, you can solve it finding the pattern, okay. Find out the hint here is, see, last digit is 2. In previous problem, we have solved about the power of 2's. How we solve, we find out. Okay, try to find this. It's a very simple problem. Only thing is you have to understand the concept, apply it. That's all. I'm going to end here. I'm going to sign off here. And my next episode, I'm going to continue this. Okay, till then, try to solve this problem. Please subscribe to my channel. I am giving offline class and online classes also. Please subscribe to my app, Genius Book Classes for all exams. This is my app. And then in Bangalore, recently we have started our coaching institute. If you are nearby, please come to my coaching institute and try to register yourself so that you can have one-to-one conversation. I can give you wonderful guidance. You can achieve your dreams. You can do IAS or whatever exam you are aspired for. So, and if you can't do all those things, at least subscribe to my channel. I am going to give you a wonderful information, knowledge, learning skills, and I am going to make you more smarter. Okay, no book, no teacher, no coaching institute can make you a smarter guy. Okay, I'll entertain you with all the inputs, with all my knowledge, with all my experience. Along with that, I am going to make you smarter, more intelligent, so that you can be successful in your aspired exam. Thank you very much. Subscribe to my YouTube channel. Bye bye. See you.